All right, everyone. We're going to start up with 6.4. That is going into what we call specifically arithmetic sequences. We will jump into 6.5, which is geometric sequences. Sort of similar in, I guess, idea with this one, but let's focus one at a time. Arithmetic sequences is a very specific name given to a sequence where the difference, that should already give you a hint of what I mean, what you're going to see, between consecutive terms is constant. What does that mean? Well, it basically means it has a, quote unquote, a common difference. Once again, what the heck does that mean? How about we go through an example and you'll have a better understanding. I'm going to pull a arithmetic sequence, or rather a regular sequence, straight out of the textbook. How about we start with this? -4, 0, 4, 8, 12, 16, and so on and so forth. Okay. What do you see? What do you notice? What's the pattern? Going once, going twice. I'm hoping that you recognize that every single term is larger than the previous term by an additional 4. Okay. Another way you can do that is simply just do this, right? Like 0 minus the previous one, which is +4, 4 minus the previous term, which is a 4, 8 minus the previous term, which is a 4. Does that look familiar? You're basically doing first differences. That's going all the way back to grade 9. If you're not sure what the heck I'm talking about, I hope this refreshes your memory. Right? If the numbers I have is 2, 4, 6, 8, 10, 12, 14, how do you calculate the slope? Or how do you calculate the what do you call it? I guess the difference, right? How do you calculate the constant of variation? Well, you take the next number subtracted by the previous y value, 6 subtracted by the previous value, 8 subtracted by the previous value. You get the point. We're doing the exact same thing. Subtract one of the terms with the previous value and you will get the common difference. In this case, the common difference is a 4. Why common? Well, because every single step of the way you see the same number. Why difference? Because to find it, we have to subtract. Hope you get the point. Okay, I'm going to move on. And in doing so, we call this an arithmetic sequence because it's so predictable. And being predictable, we are able to actually turn all of this into an explicit formula, right? If I had this and I asked you what that was, how would you write it? Want to take a guess? You can stop the video and give it a shot. Assuming that you gave yourself an honest shot at it, what we're going to do is try to write this by giving it a starting point and writing out how many times we're going to add 4. Consider this, even before I get there, okay? I know that I am going to be, so some number, I know I'm going to be adding 4, adding 4, adding 4, adding 4, adding 4, so on and so forth, for as many times as I need to get to Tn. But what am I adding 4 to? I'm adding 4 to the first number, of course. In other words, Tn is the first term plus 4 a certain number of times. Does that make sense? Pause the video or go back and try to listen to my explanation again. For those of you who want to continue, notice how this equation, it is in terms of the nth term, but all of a sudden I randomly added an x there. I don't want to do that. Is there a way we can write an explicit formula using the variable n? Well, using your logic, consider how many times I am adding 4. If I have t1, that's just -4. If I have t2, how many times did I add the 4? Just once, right? If I have t3, how many times did I add the 4? Once, and then twice, right? And if I have T4, I start with a -4. How many times did I add the 4? This gives me T2, this gives me T3, and this gives me T4. Long story short, the amount of times that I'm adding the common difference is 1 less than the actual term number. So using your logic, you can actually write this down. Tn is going to be whatever I start with, in other words, T1, let's use T1. T1 plus the common difference, right, multiplied by 1 less than the actual term number. This is essentially your explicit formula, but it sort of also goes with a little bit of, it gets confusing. So as opposed to using actual terms and ends and certain things like that, we actually give each of these numbers inside the explicit formula a particular variable, just to make it more universal. Taking this concept, we are going to write the explicit formula for the arithmetic sequence as Tn equals a plus n minus 1 multiplied by the common difference, or basically a plus n minus 1 times d. Okay, where, if you're confused, the a is the first term, okay, d is the common difference, and of course, the n is the term number. That's it. So the meat and potatoes of this section is this formula. And if we say that it is an arithmetic sequence, you can take to heart, or you can assume that the sequence is going to follow this particular formula. Shall we see how this runs its course in a puzzle-like question? Here we go. Here's an example. This is an example from, how about example 2 of page 383. Okay, they say, consider this sequence. That's all they say. Is this sequence arithmetic? How do you know? Well, you can just use your logic and say, hey, every single time I'm doing adding of 6, or you can show me mathematically and say, well, 19 minus -13, like first difference is a, sorry, what am I doing? It's subtracting by 6 every time, isn't it? Sucks to be me. How embarrassing. -19 minus a -13 is -6. And -25 minus a -19 is -6. It's constant. So we know it's going to be arithmetic sequence. Okay? Using this, what would be my explicit formula? Well, what's my first term? My first term is 13. What's my difference, common difference? It's a -6. If that's the case, my explicit formula is going to be the first term plus n minus 1 times -6. So no matter what term I want to find, all I have to do is plug it in, subtract by 1, and multiply by -6. How about we simplify this and write this as -13 minus 6 times n minus 1. Just makes it a little cleaner. All right? Part C asks, okay, now that you have a formula, can you give me the 15th term? Not a problem. -13 minus 6, 15 minus 1, so that turns into 14. And that makes sense because I'll be subtracting 6 14 times. 84, which means negative 97. There it is. Part D asks, determine a recursion formula for the sequence. Well, the answer is right there in the textbook, but I'll let you do that yourself. I want to go through another harder question because you'll be seeing a lot more of these kinds of questions, the harder ones from me in the future. Okay, if you don't want to wait for me as I erase all of this, you may want to use the timestamp in the comment section or the description section. And yeah, get to that. Okay. The next example is example 4 that comes from page 384. Okay. In an arithmetic sequence, they told you that it was arithmetic. T11 is going to be 72. T21 is 142. What is the value of the first term and of the common difference? What is A? What is D? That's all they give you. The textbook uses elimination, something that you have learned in grade 10. So I'm going to do that, and then I'm going to try doing a different method where you simply use logic to solve it. Okay, let's start. T11 is 72, but that is also equal to A plus the common difference multiplied by how many times? 10 times 11 minus 1, right? T21, that is 142, but what is it also equal to? It is the first number added by the common difference, how many times? 20 times, because it's 21 minus 1. So I have two formulas. I have 72, which equals A plus 10D. I have another equation that's 142 equals A plus 20D. Do you see where this is going? Does that look familiar to you? It better. Don't disappoint me, my students. Come on, you're better than everyone else, right? If I were to eliminate, because positive A and positive A are going to subtract, 72 minus 142, that's a negative 70. A minus A, that's nothing. And 10 minus 20, so D is equal to negative 3 point. Sorry, I made a mistake. 10 minus 20 isn't 20, people. It's 10, okay? So divide both sides by negative 10, I get a positive 7. The common difference is positive 7, which makes sense because I am adding to get to a larger number, right? Let's move on. So if I know what D is going to be, I'm going to choose any of these equations to help me out. Just to use smaller numbers, 72 is equal to A plus 10 times D, which is A plus 70. Subtract both sides by 70, A is equal to 2. Bam, A is 2, D is 7. So far, so good? Okay, that, I'm going to highlight it as method 1, okay? That is method 1. I would like to draw your attention to the logical way, which is just as good, but sometimes it may be helpful, sometimes it may not. Let's take 72. Okay? And then that's term 11, right? And let's go to term 21, T11 and T21. That is 142. Between 11 and 21, how many times did I have to add the common difference? Going once, going twice, 10 times. That means between 72 and 142, the difference is going to be 10 times the common difference. Do you see how simple that gets? 142 minus 72 is 70 equals 10D. And automatically, we've already gotten ourselves into we've sort of gotten ourselves into that situation already just by using logic. Again, I would say it's faster, but again, sometimes it may not be as helpful, nor, and also it sort of might open up some room for error because you're simply using logic here, right? And then if that's 72, so again, so T11 would be some value plus 7 multiplied by 11 minus 1, that is a plus 7 times 10. So a is going to equal 2. So you get the answer in either way. But I'll leave it to you which way you feel is most comfortable, or what you feel makes you more confident. Like if you like to use logic because you don't want to memorize all this like algebra or whatever, but that sort of makes you nervous because you feel like you're not studying all of it or you don't know all of it, well then learn both. Okay, I would highly recommend you do that anyways. Test your mettle, regardless of what you decide to do. Test your mettle by doing the questions in the top right corner. That would be page 385, numbers 1, 4, 6, 7, 10, 14, 15. When you have done so and you're feeling a bit more confident about it, tune in to the next video. Okay, see you there.